All right, so one thing we haven't talked about is the idea of what's called internal resistance. Internal resistance is the idea that, as you know, batteries just over time lose their effectiveness. Batteries don't maintain their ability to pump current through the same. Um, One way that we can explain that is the idea that inside a battery there's this internal resistance. Um, and that internal resistance, we use the symbol lowercase r just because it's usually a fairly small resistance compared to what the battery is powering. It's the idea if you have your battery and you've been using it for a while, especially in your phone, all of a sudden it heats up. Um, but that resistance keeps increasing until the battery doesn't provide enough um, electric potential difference, enough current to actually um, power whatever it is you're doing in the circuit. So the model we use for that is the idea that inside the battery there is a source of energy, and we call that the electromotive force. That goes back to Michael Faraday, a British physicist. Um, and that symbol we use there is the script letter E for the EMF, and it's just a constant that's provided by the battery. It's whatever is provided by the chemical reaction that causes the battery to pump the current through. But then uh, the internal resistance of a battery removes some of that voltage, and so the potential difference provided by the battery is going to be the ideal value, that EMF, minus the current times resistance. Same, just normal Ohm's law. It's just losing some energy. And so we kind of look at it, and you can kind of think of it as, here's your battery in the little bit darkened. So your ideal battery here, there's a small internal resistance. It provides, with no current, it would provide the full voltage. But now as you increase that, you get less and less of the energy going to the resistor, more of it going to this internal resistance. And then as you get, when the battery is new, it has a low internal resistance, um, and so you get most of the current that you're supposed to. But as it's going through there, the higher internal resistance, the less current goes to your actual desired thing. So whatever you're trying to run, your toaster or your phone or whatever it is. Different types of batteries will discharge at different rates. Normal dry cell batteries, the AA, AAA batteries that you see, um, they weaken over time. If you've ever used like a flashlight using a C or a D battery, at first it's really bright, but then eventually it just gets dimmer and dimmer until you can't use it anymore. There are different types of batteries, mercury cell batteries, lithium ion batteries, that will have a much longer discharge time and a much lower internal resistance, but all batteries will have that will change over time. So when you use a battery, the current goes through, it uses some of the energy, and then it goes through there. But when you're charging a battery, so whenever you charge your phone, you kind of pump current through the opposite way. And what it does is it lowers that internal resistance until you get to a minimum value. Now, you all know when you have a brand new rechargeable battery, you can get that internal resistance down to a very low value very quickly. But the longer you've had that battery, the harder and harder it is to get it fully charged or kind of remove that internal resistance. Here's an example, a numerical example. Nice clean numbers here. If our external resistance is 5.9 ohms and our internal resistance is 0.1 ohms, that means our total resistance is going to be 6 ohms. So if we have a 12 volt battery and 6 ohm resistance, that means 2 amps of current are going to flow. But if you look at it, inside the battery, you've got your 12 volts here, but if you have 2 amps of current, then 0.2 volts are going to be used up inside the battery itself. So instead of putting out 12 volts, you're going to be putting out 11.8 volts, and that's all that's going to get to your resistor here, because some of it is used up in the battery.